Hello viewers, welcome to IIT PAL Mathematics channel. So, this is lecture 3 on integral calculus. So, let us do some problems based on integration. So, first let us recall some facts about area enclosed by curves. So, suppose we have a function f x is greater than equal to 0 . So, we have the graph of this function y equal to f x, which lies above the x axis, and we have this line x equal to a and x equal to b. So, the area bounded by the curve y equal to f x, the lines x equal to a, x equal to b, and the x axis is given by the definite integral of a to b of f x dx. Right. So, this definite integral gives the area under the curve y equal to f x from x equal to a to x equal to b. Now, suppose we have two functions. So, the area between the curves y equal to f x, y equal to g x, and x equal to a and x equal to b is given by. So, suppose we have two functions f x and another function g x, and we need to find this area. So, in this figure f x is greater than g x. So, this will be integral from a to b of f x minus g x dx if f x is greater than equal to g x. This is because the integral of a to b f x dx gives you the area between the curve y equal to f x and x axis from x equal to a to b, and the other one integral of g x dx from a to b gives the area under this one. So, the difference gives the area. In general, this area will be equal to integral a to b of mod of f x minus g x dx. So, we have to look at the upper curve and lower curve and take the difference and then integrate to find the area. So, now let us look at some problems. So, first one, let us find the area enclosed by the curves y equal to sin x plus cos x and y equal to mod cos x minus sin x over the interval 0 to pi by 2. So, let f x denote the first function sin x plus cos x and g x is mod cos x minus sin x for x belonging to 0 to pi by 2. So, in the interval 0 to pi by 2 both sin x and cos x are non negative. So, here note that this g x is mod cos x minus sin x, this is less than equal to mod of cos x plus mod of sin x, this is by the triangle inequality, and because x is in 0 to pi by 2, this is equal to cos x plus sin x for x in 0 to pi by 2, but cos x plus sin x is same as f x. So, we have in this case f x is greater than equal to g x for x in 0 to pi by 2. So, therefore, the required area is equal to integral of f x minus g x dx from 0 to pi by 2. So, this is equal to integral 0 to pi by 2 f x is sin x plus cos x minus g x is mod cos x minus sin x dx. Now, we have mod cos x minus sin x, this is equal to cos x minus sin x if cos x is greater than equal to sin x, and that is if x is between 0 to pi by 4, we know that cos x is bigger than equal to sin x, and for x between pi by 4 to pi by 2, sin x is bigger than cos x. So, this will be equal to sin x minus cos x. So, therefore, this integral we can write as integral from 0 to pi by 4, and then we have sin x plus cos x minus cos x minus sin x dx plus pi by 4 to pi by 2 sin x plus cos x minus sin x minus cos x dx. So, this is equal to the first one, cos x cancels and we have 0 to pi by 4 2 times sin x dx plus 0 to pi by 4 and pi by 4 to pi by 2 2 cos x dx, and then this is simply minus 2 cos x from 0 in pi by 4 plus 2 sin x from pi by 4 to pi by 2, which is equal to minus 2 into 1 by root 2 minus cos 0 is 1 plus 2 times sin pi by 2 is 1 minus sin pi by 4 is 1 by root 2. So, this is equal to 4 times 1 minus 1 by root 2 or 4 minus 2 root 2. So, this is the required area. So, of course, in this question you could have drawn the graph of these functions sin x plus cos x and mod cos x minus sin x, and then found this area, but it is not even necessary to draw the graph, because we can see that in this case f x is greater than equal to g x. Now, let us move to question number 2. Again we will find an area. So, find the area of the region in the first quadrant given by x y such that x times y is less than equal to 8 and 1 is less than equal to y less than equal to x square. So, let us first draw this region. So, we have x y equal to 8 is the rectangular hyperbola, and y equal to x square is the parabola like this. So, first let us see where these two intersect. So, we have this is x y equal to 8 and this is y equal to x square. So, if I put y equal to x square, then I get x times x square, that is x cube equal to 8. So, x is equal to 2. So, this point is 2 comma 4, and another curve is y equal to 1. So, y equal to 1 is this straight line. So, now let us figure out the region. So, again this y equal to 1 intersects the parabola y equal to x square at the point 1 comma 1, and it intersects the rectangular hyperbola x y equal to 8 at y is 1. So, x will be 8. So, this is 8 comma 1. Now, what is the region? So, region is given in the first quadrant by x y less than equal to 8. Let me draw this x y less than equal to 8 in this yellow. This is the region x y less than equal to 8 is below this curve y equal to 8 by x, and y has to be bigger than equal to 1 and less than equal to x square. So, this yellow region is x y less than equal to 8 and in the first quadrant. Now, let us draw the region y greater than equal to 1 this is above this line. This is the region y is bigger than equal to 1 in first quadrant. And the region y is less than equal to x square is this region in yellow, in orange. Because this is below the curve y equal to x square. So, what we have to find is the intersection of these regions. So, that is nothing but this region in red. So, this is the area that we have to calculate. Now, once we have drawn this, this is now easy to do. So, here what is the upper curve? Let me write this upper curve f x. This is equal to the upper curve is x square if 1 is less than equal to x and less than equal to 2. From 1 to 2, if you see, if this is x equal to 1, this is 2 and this is x equal to 8. So, from 1 to 2 it is y equal to x square, and from 2 to 8 it is y equal to 8 by x, and the lower curve g x is simply y equal to 1 for x between 1 to 8. So, what we have to find, the area is integral from 1 to 8 of f x minus g x dx, which is equal to integral from 1 to 2 of x square minus 1 dx plus 2 to 8 of 8 by x minus 1 dx. This can be easily evaluated. This is equal to x cube by 3 minus x from 1 to 2 and plus 8 log mod x minus x from 2 to 8. This is equal to 8 by 3 minus 2 minus 1 by 3 minus 1 plus 8 log 8 minus 8 minus 8 log 2 minus 2. And this is equal to 7 by 3 minus 1 plus 8 log 4 minus 6, which is equal to 8 log 4 is same as 16 log 2 minus 14 by 3. So, this is the answer for this. Now, here note that because this upper curve was different in different interval from 1 to 2 and 2 to 8, we had to calculate this area by splitting it into sum of two integrals. This problems can also be done in another way. So, let's write another way. let me draw this region again. We have y equal to x square, we have this x y equal to 8 and y equal to 1. This point is 2 comma 4, this is 1 comma 1 and this is 8 comma 1. Now, here you can see that this region is bounded between these two lines y equal to 1 and y equal to 4, and the left curve here is this one y equal to x square and the right curve is y equal to 8 by x. So, this area I can write as, instead of integrating with respect to x, if I do with respect to y, and this is the integral from 1 to 4 of 8 by y minus y equal to x square, means x is equal to root y dy. So, the advantage here is that we can evaluate this as just one integral. So, this is equal to 8 log y from 1 to 4 minus y to the 3 by 2 by 3 by 2. So, this from 1 to 4, which is equal to 8 log 4 minus 2 by 3 times 4 to the 3 by 2 minus 1, which is equal to 16 log 2 minus 2 by 3. 4 is 2 square. So, this is 8 minus 1. So, 16 log 2 minus 14 by 3. So, in some problems, instead of writing as integral of f x dx, we can do integral of some f of y dy, and that might be easier to evaluate. Let us move to question number 3. Here it is given that the line x equal to alpha divides the area of the region r equal to x y in R2 such that y is between x cube and x is between 0 and 1. So, the line x equal to alpha divides this region into equal parts. Then which of the following options are correct? The first option is alpha is greater than 0 and less than equal to half. Second is alpha is greater than half and less than 1. C is 2 times alpha to the 4 minus 4 alpha square plus 1 equal to 0, and D option is alpha to the 4 plus 4 alpha square minus 1 equal to 0. So, first we should see what is the region R. The region R is bounded by the curve y equal to x cube and y equal to x for x between 0 and 1. So, we have y equal to x equal to x cube, looks like this. This is x equal to 0 and x equal to 1. So, this is the region R. So, first let us calculate what is the area of the region R. Area of the region R is equal to integral from 0 to 1 of the upper curve is x and the lower curve is x cube. So, x minus x cube dx, which is equal to x square by 2 minus x to the 4 by 4 between 0 and 1, which is equal to 1 by 2 minus 1 by 4. So, this is equal to 1 by 4. So, that is the total area of this region R. Now, we have to find this line x equal to alpha, which divides this in equal parts. That means that the integral, so alpha is such that the integral of 0 to alpha of x minus x cube dx, this should be equal to half of the area of region R, which is 1 by 4. So, this is equal to 1 by 8. Now, this will give alpha square by 2 minus alpha to the 4 by 4 is equal to 1 by 8, which implies if I multiply by 8 and 4 alpha square minus 2 alpha to the 4 is equal to 1, which means 2 alpha to the 4 minus 4 alpha square plus 1 equal to 0. So, if we see the options, this is same as option C. So, option C is correct. Also, immediately now we can rule out option D, because if we see that alpha satisfies this option C, 2 alpha to the 4 minus 4 alpha square plus 1 equal to 0, and if it also satisfies alpha to the 4 plus 4 alpha square minus 1 equal to 0, then if we add these two, then we get 3 alpha to the 4 is equal to 0, which will give alpha equal to 0, but clearly alpha equal to 0 does not satisfy this option C. So, this D option is wrong. Now, what about option A and B? So, one way is to this equation is quadratic in alpha square. So, we can solve for alpha square from this equation and hence get the value of alpha. Another simpler way is that we have to see whether alpha is less than equal to half or alpha is bigger than half. So, what we can do is simply calculate this area for alpha equal to half. So, if we calculate 0 to half of x minus x cube dx, this will be equal to, just put alpha equal to half. So, this will be 1 by 8 minus 1 by 2 to the 4 by 4. So, this is 1 by 8 minus 1 by 64, which is 7 by 64, which is less than half. So, if we integrate from 0 to half, we get the area which is less than half. So, therefore, alpha must be bigger than half. So, This implies alpha has to be between half and 1. So, that means that option B is correct and A is wrong. Therefore, option B is correct. Of course, we can calculate the value of alpha directly. We have 2 alpha to the 4 minus 4 alpha square plus 1 equal to 0. This will imply alpha square is equal to 4 plus minus square root of 16 minus 8 by 4. This is equal to 1 plus minus 1 by root 2. Now, since alpha has to be less than 1, we have alpha square equal to 1 minus 1 by root 2, and this will imply alpha is square root of 1 minus 1 by root 2, and you can see that this is bigger than half. But we did not have to actually calculate this value of alpha. Let us move to next problem, question 4. Let f be a function from minus 1 to 0 infinity be a continuous function such that f of x is equal to f of 1 minus x for all x in minus 1 to 2, and let r 1 equal to integral of minus 1 to 2 of x times f x dx, and r 2 be the area of the region bounded by y equal to f x, x equal to minus 1, x equal to 2, and the x axis. Then we have 4 options given. First is r 1 equal to 2 r 2, B is r 1 equal to 3 r 2, C is 2 r 1 equal to r 2, and option D is 3 r 1 equal to r 2. So, let us write what is r 1. R 1 is given by integral from minus 1 to 2 of x times f x dx. Now, we will use the fact that it is given that f of x is same as f of 1 minus x. So, this is equal to minus 1 to 2 of x times f of 1 minus x dx. Now, putting 1 minus x equal to y, we have this integral minus 1 to 2 of x times f of 1 minus x dx is equal to integral from minus 1 to 2 of 1 minus y times f of y dy. So, this is equal to integral from minus 1 to 2 of f y dy minus integral minus 1 to 2 of y f y dy. So, therefore, this r 1 is equal to the first integral minus 1 to 2 f y dy is nothing but r 2, and this second integral is again r 1. So, this implies 2 r 1 is equal to r 2. So, we have option C is correct. Let us move to question number 5. Find the area of the region x y in R 2 such that y is bigger than equal to square root of mod x plus 3 and 5 y is less than equal to x plus 9 is less than equal to 15. So, let us try to draw this region. So, first we have this 5 y less than equal to x plus 9 less than equal to 15. This is equivalent to 5 y is less than equal to x plus 9 and x is less than equal to 6. So, we have y is less than equal to x plus 9 by 5 and x is less than equal to 6. So, this region we have x equal to 6 and y equal to x plus 9 by 5 is the straight line. This intersects x equal to 6. If we put x equal to 6, then y is 6 plus 9, 15 by 5 is 3. So, this is the point 6 comma 3, and when x is 0 it is 9 by 5 and y becomes 0 when x is equal to minus 9. So, this is minus 9 comma 0. This is the straight line y equal to x plus 9 by 5. So, y is less than equal to x plus 9 by 5 is the region below this line, and x less than equal to 6 is the region to the left of the line x equal to 6. So, this gives this region which is bounded between this. Also, we have to see this restriction that y is greater than equal to square root of mod x plus 3. So, this part is the region 5 y less than equal to x plus 9 less than equal to 15. Now, let us look at y equal to square root of mod x plus 3. This is equal to square root of x plus 3 if x plus 3 is non-negative, that is x is greater than equal to minus 3, and it is square root of minus of x plus 3 if x is less than minus 3. So, this is of course symmetric about x equal to minus 3. So, we can try to draw this for x bigger than equal to minus 3. So, we have this is x equal to minus 3 and y equal to square root of x plus 3, this is this part of the parabola like this. This is y equal to square root of x plus 3 for x bigger than equal to minus 3, and this f x is symmetric about this. So, this will be the other side, it is like this. So, this is the graph of f x, this part is y equal to square root of minus x plus 3. Now, what we have is the region is y is bigger than equal to f x. So, y bigger than equal to f x will be the region above this. This is the region y bigger than equal to square root of mod x plus 3. Let us also see where this curve intersects the line. So, y equal to square root of mod x plus 3 intersects the line x equal to 6 at, if we put x equal to 6, then y is equal to 3. So, at 6 comma 3, which note is also the intersection of these two straight lines, and the line y equal to x plus 9 by 5 at the points minus 4 comma 1 and 1 comma 2. This is by equating this square root of mod x plus 3 equal to x plus 9 by 5, and then you can square and you can find this point of intersection. So, let us draw this. The region is as below. We have this is minus 3 comma 0, this is the intersection 6 comma 3, this is the line y equal to x plus 9 by 5, this is x equal to 6, and this is y equal to f x. So, the region is this region that we have to find the area, and these points are minus 4 comma 1 and another point of intersection is here, which is 1 comma 2. This part is y equal to square root of x plus 3, and this is y equal to square root of minus x plus 3. So, now we can find this area by integrating this upper curve, which is in this case the straight line, minus the lower curve, which is this part of these two parabolas. So, to find this area, Note that here the upper one, because it's a straight line, we can find this, let us call these points as A, B, C and D. So, this is area of trapezium ABCD minus the area of these two. So, minus what is the area of this left part will be integral from minus 4 to minus 3 of square root of minus x plus 3 dx, and then we have to subtract minus integral from minus 3 to 1 of square root of x plus 3 dx. Let us evaluate these integrals. So, integral minus 3 to 1 square root of x plus 3, this will be equal to x plus 3 raised to power 3 by 2 times 2 by 3 minus 3 to 1, this is 2 by 3. We put x equal to 1, this is 4 to the 3 by 2, which is 8 minus 0, this is 16 by 3, and integral of minus 4 to minus 3 of square root of minus x minus 3 dx, this will be equal to minus x minus 3 raised to power 3 by 2, then we have minus 2 by 3 from minus 4 to minus 3, this is minus 2 by 3 times at x equal to minus 3, this is 0 minus, when we put x equal to minus 4, this will be equal to 1. So, this is equal to 2 by 3, and area of trapezium ABCD is equal to half times, this will be AD plus BC times CD. So, this is equal to half, AD is equal to 1, BC is 2, 1 plus 2, and CD is equal to 1 minus minus 4. So, that is 5. So, this is equal to 15 by 2. So, therefore, area of the region is equal to 15 by 2 minus 16 by 3 plus 2 by 3, that is 15 by 2 minus 18 by 3 is 6, that gives 3 by 2. So, this is the answer. Let me do one more problem. Let f x equal to integral x to x square plus pi by 6 2 cos square t dt for every real number x, and f from 0 half to 0 infinity be a continuous function for each a in 0 to half, if f prime a plus 2 is the area of the region bounded by x equal to 0, y equal to 0, y equal to f x and x equal to a, then find the value of f of 0. So, what is given to us that this f prime a plus 2, this is the area of the region bounded by this curve y equal to f x dx from 0 to a. What is given to us is f of x is equal to integral from x to x square plus pi by 6 2 cos square t dt. Note that we only need f prime. So, we should not try to evaluate this integral. So, this implies f prime x, we know that to find the derivative of this integral from two functions of x, this will be given by 2 times cos square of the upper limit is x square plus pi by 6 times the derivative of x square plus pi by 6 is 2 x minus 2 times cos square of the lower limit x times the derivative of the lower limit, which is 1. So, this is equal to 4 x cos square x square plus pi by 6 minus 2 cos square x. So, therefore, f prime a plus 2, which will be equal to 4 a cos square a square plus pi by 6 minus 2 cos square a plus 2, which I can write as 4 a cos square a square plus pi by 6 plus 2 sin square a, because sin square a is 1 minus cos square a. Now, this is given to be equal to integral. So, therefore, integral from 0 to a of f x dx is equal to 4 a cos square a square plus pi by 6 plus 2 sin square a, and we have to find the value of f of 0. So, we can differentiate this, differentiating with respect to a, we get f of a is equal to, derivative will be 4 times cos square a square plus pi by 6 plus 4 times a times the derivative of cos square, that is 2 cos a square plus pi by 6 times sin a square plus pi by 6 times 2 a plus derivative of 2 sin square a will be 4 times sin a times cos a. Now, put a equal to 0. So, f of 0 is equal to 4 times cos square pi by 6 plus we have a times this. So, this will be 0 and sin of 0 is 0. So, 0 cos of pi by 6 is root 3 by 2, root 3 by 2 square. So, this is equal to 3. So, therefore, f 0 is equal to 3. Okay, so this finishes lecture 3 on integral calculus. In the next lecture, we will do some more problems. Thank you.